Hello. Today, I'm going to talk about agents and monitoring systems. First, it's important to clarify that I'm referring to host-based monitoring agents. These are dedicated agents that are installed on a server or endpoint as part of the monitoring system. I'm not referring to agentless monitoring mechanisms that rely on existing monitoring and communication protocols such as SNMP, DCOM, WMI, WinRM, and SSH. With these protocols, no dedicated monitoring agent is installed. Instead, the monitoring system uses services that already exist within the operating system. One of the first things you should check before choosing a monitoring solution for your organization is whether it supports agent-based monitoring and not just agentless monitoring. Agent-based monitoring offers several significant advantages. It can collect more detailed information from the operating system. It can run local checks and scripts. It provides deeper monitoring of applications and services. It works more efficiently in cloud and container orchestration environments, and it reduces dependence on external management protocols. At the same time, agentless monitoring also has advantages. For example, it is simpler to deploy and easier to maintain. In many cases, the ideal solution is a monitoring platform that allows you to combine both approaches as needed. In other words, a solution that supports both agent-based and agentless monitoring. The direction of communication between the agent and the monitoring system is one of the most important aspects of security and system architecture. When evaluating a monitoring solution, you should determine which side initiates the communication. Does the monitoring server initiate the connection to the agents, as shown in the current diagram? When the monitoring server initiates the communication, it is usually necessary to open inbound ports on the monitored servers. The second option is for the agent to initiate the connection to the monitoring server and send its data. This model is very common in modern SaaS platforms and cloud-based monitoring solutions. Some monitoring platforms support both communication models and even allow you to combine them. Examples include SolarWinds and Zabbix. With these platforms, you can choose whether the agent initiates the communication or the monitoring server does. This is generally the most flexible approach. From a security perspective, many organizations prefer the model in which the agent initiates the connection. However, that is not always the best choice. Let's look at two different scenarios. Here we have a core network and a DMZ network. The monitoring server is installed in the core network. It initiates the connection to the agents located in the DMZ. In other words, this is a server-initiated communication model. The reason for choosing this model is security. In most organizations, security teams do not want to allow connections from the DMZ into the core network. The core network is considered the more trusted and secure environment. In the second scenario, we have a primary monitoring server located in the core network. The primary server initiates the connection to a monitoring proxy server. In other words, the communication between the primary monitoring server and the proxy uses a server-initiated model. The agents located in the DMZ initiate their connections to the proxy. As a result, this is a hybrid deployment. It combines both server-initiated and agent-initiated communication. This is possible because the monitoring platform supports a hybrid communication model. In general, having the flexibility to support both agent-initiated and server-initiated communication makes firewall rule design much simpler. It also makes it much easier to work with the information security team. From a resource utilization perspective, an agent is a continuously running component on the operating system. For that reason, it's important to evaluate its impact on local system resources. You should measure CPU utilization under both normal operation and peak load. You should also evaluate memory consumption, disk usage and write activity, network bandwidth utilization, and the impact on the response time of other applications running on the monitored server. It's recommended not to rely solely on the monitoring vendor's published figures. Instead, perform your own performance and load testing during the POC. When it comes to agent management and updates, the larger your environment becomes, the more important centralized agent management is. You should check whether the monitoring platform supports remote agent deployment, centralized agent upgrades, centralized configuration management, automatic configuration distribution, detection of missing agents, monitoring of agent health, and other management capabilities. In large organizations, these features can save a tremendous amount of administrative effort. It's also worth checking whether the agents are used only for data collection or whether they can also perform actions on the monitored servers. Beyond the technical capabilities of the agent, there is also a conceptual question. Does your organization want the monitoring agent to actively perform actions on the operating systems where it is installed? Or do you prefer the agent to be used strictly for monitoring? These actions may include running scripts that modify system configurations, rebooting servers, performing automated remediation, restarting failed services, collecting specialized log files, freeing up disk space, and similar operational tasks. This essentially extends the monitoring platform beyond its traditional role. It gives the platform capabilities that are typically associated with automation and operations tools, in addition to its monitoring functions. The key question is whether this approach aligns with your organization's operational and security policies. The security of the agent itself is a topic that is often overlooked when selecting a monitoring platform, and that's unfortunate. You should evaluate how communication is encrypted. Today, encrypted communication is expected, but the real question is whether the implementation meets your organization's security standards and compliance requirements. You should also verify whether mutual authentication is supported. How are encryption keys and certificates managed? Can you restrict which commands the agent is allowed to execute on the monitored server? Can the agent be hardened, for example, by running it with least privilege permissions? At the end of the day, an agent that is capable of executing commands on a server operates with significant privileges. For that reason, it should be treated as a security-sensitive component in its own right. Another important consideration is what happens if communication between the agent and the monitoring server, or the monitoring proxy, is interrupted. This could be caused by a failure of the monitoring application server or the database server. In either case, it affects the monitoring platform itself and, of course, its communication with the agents. Advanced monitoring platforms with well-designed agents can store metrics locally, buffer collected data, transmit the data once communication is restored, and preserve data continuity. In large environments or remote locations, this is an extremely valuable capability during outages. As we wrap up, it's also important to evaluate the agent support for different operating systems and environments. For example, Windows, Linux, Unix, containers, Kubernetes, virtualization platforms, and more. Not every monitoring platform provides the same level of agent functionality across all operating systems and environments. This applies not only to operating systems, but also to technologies such as containers and orchestration platforms. To summarize, in most organizations, the agent is arguably the most important component of the monitoring architecture. Beyond dashboards and alerting capabilities, it's essential to carefully evaluate the agent's deployment, management, security, communication, and platform support. These factors have a direct impact on how easily the monitoring platform can be deployed, maintained, and scaled over time.